Welcome to the Regional Center of Excellence for Root and Tubers. Here is a Crop Research Institute in Ghana, and as you are aware, we are hosting the CRI-iREACH Technology Park in Kumasi. Basically, the Technology Park is a concept that we are using to bring to the attention of the stakeholders what we have been researching into, the technologies we've been able to come up with. And we do so with our sister institutes like Food Research Institute of Ghana, Plant Genetic Resource Research Institute, and Soil Research Institute. And we do so from the forest savanna transition to the coastal savanna. The Guinea savanna is in the mandate of another sister institute, Savannah Agricultural Research Institute. These parks came about when the realization came that most of the technologies being developed by various stakeholders under the USAID program, basically there's a big disconnect. So a body was set up to look into it. And this brought into being the CRI-iREACH program, Innovative Research, Extension, Advisory, and Coordination Hub. And the CSIR-Crop Research Institute was mandated to set up the parks. So here, all stakeholders involved in the value chain of the crop are brought together to the table, and then we will make available to them the technologies that are ready to go. As an institute, I've been engaging other stakeholders in giving the rights to the varieties and other technologies to them on contract basis, and we provide the technical backstock for them to apply them. So it is very interesting that in the past, technologies have come from as far as Senegal. Kansas State University has also provided some varieties, some technologies. We know of the machineries for executing most of the hard stuff of our technology.
You are welcome to the CRI-iREACH Coral Technology Park. I'm Dr. Mrs. Mary Otiwa Osei Asante, a research scientist, a head of section for cocoyam. And on this park, we are demonstrating 3 technologies for rapid cocoyam multiplication. Cocoyam is a food security crop, a resilient crop, which its propagation, when done well, helps the home to be secured. Both leaves, culm, and petioles are used as food or feed for animals. The leaves are used as spinach. The culms and cormels are used as the major protein source and carbohydrate source, either as feed for pigs or human beings. The petioles are excellent for pregnant sows, which when they are fed, they give a high litter. The crop production is challenged with low planting materials, and therefore farmers are not able to plant at the required planting density due to the inadequate supply of planting materials. So we are demonstrating 3 technologies that will aid rapid multiplication of the cocoyam as well as the taro under the technology pack. So we go in and I will demonstrate the activities which are ongoing, so you'll be familiarized with it, and you also be able to spread the news to the farmers to adapt to these technologies. As we enter, you see taro, we see the cocoyam plant, and we see a humidified chamber for all the three activities for improved planting material multiplication. For the humidified chamber, under it or within it, we have combs of cocoyam where we have destroyed the apical meristem in order to enhance the sprouting of the lateral buds or lateral meristems. These buds or these combs, when they are inserted in the humidified chamber, which contains sawdust only. The sawdust are fresh sawdust in order to create heat. The heat forces the bud to sprout. Each bud or each comb is expected to give us about 14 to 24 plantlets, and it is watered every other day. That is 3 times a week. So we are plucking and planting. You pluck and plant as when the plants are ready for plucking. When field conditions are also ready, when you pluck them from the mother comb, we send it directly to the field for planting. When field conditions are not ready, we put them in the polythene bag, waiting for rain or irrigation. The second multiplication technique for rapid planting material generation is the split comb technique. Each comb has the ability to give us about 12 to 16 sets. We cut them to the set of 3 to 5 grams when we weigh. You dust it, ensuring that each set has a bud. It's from the bud that the plant would sprout. So the sets are planted in a nursery poly bags, which has a ratio of sand to sawdust 3:1. The sawdust is to ensure that it retains some moisture and also control weeds. Watering is done every other day so that the plants can sprout, and within 6 weeks, it is also sent to the field for planting. The third technology or technique for rapid multiplication is done on the taro. Taro, we know, produces side shoots or suckers, which the farmer also uses to plant, because the comb is the part that we feed on. So it's the suckers. The suckers are also usually limited in number. So the stolon multiplication technique is also demonstrated here for rapid multiplication of planting material. As you can see, the stolons on each plant is about 5 under the screen house or the shade house here. Each 5, we are able to generate 4 to 7 plantlets from it, because we are going to cut them by the nodes and internodes. And when we cut them by the nodal cuttings, we will nurse it in sawdust, and within 6 weeks, the plants also generate into, as we can see, these plantlets which are ready for the field. So the stolon multiplication technique is also to enhance the rapid propagation of taro planting materials. On the average, you can get up to 70 plantlets from each plant using the rapid multiplication technique or the stolon multiplication technique. Whereas if you have plucked the suckers, you could have gotten as much as only 12 from one plant. And we wish farmers come regularly, visit, and get the knowledge so that they can also expand the technique on their fields and in their backyard. My name is Dr. Mrs. Mary Otiwa Osei Asante, an agronomist, a research scientist, and a head of section for the cocoyam section under the root and tuber division. Thank you.
You are most welcome to the Cocoyam Improvement Program of the Crop Research Institute. We have 4 improved taro varieties. We have CRI Hobolo, CRI Sempa, CRI Jenkwa, and CRI Yenyawa. They have maturity period of 6 to 12 months depending on the variety. And the yield of the varieties ranges from 12 to 25 tons per hectare, depending on the variety. Their potential utilizations has in use for ampesi, fufu, flour for different pastry products, and then starch for industry as well. These varieties can withstand the tallow leaf blight disease, which is causing the extent of our local assertions. And so the taro industry that has been suffered because of the tallow leaf blight, now varieties are available for farmers to use to overcome the tallow leaf blight disease in Ghana.
I'm Dr. Priscilla Francisco Ribeiro, a maize breeder and a senior research scientist with the maize breeding program. Here in Ghana at Crop Research Institute, we all know of climate change. So the breeding program works in hand with our stakeholders. And when I talk about stakeholders, I mean our farmers, our processors, and our consumers. We have to know what their problem is because it's a research institute and address such problems. So we have developed several varieties like hybrids that are climate smart and that are nutrient dense. So currently we have developed a number of them. Few amongst them that I want to talk about has to do with they being high yielding and they being climate smart and they being nutrient dense. One of such is CRI-iREACH. CRI-iREACH is the first early provitamin A hybrid to be released. CRI-iREACH is yellow in color. It is striga tolerant and it is also drought tolerant. This variety is high yielding and we believe that if it gets into the hands of farmers, because of climate change, it is early maturing, it's going to help our farmers and other stakeholders at large. We also have varieties that are intermediate maturing and one of them is CRI-Incomo. CRI-Incomo is an intermediate maturing hybrid. It is white in color, it is also very high yielding, and it is also resistant to streak and some of the diseases that we know in Ghana. And with CRI-Incomo, because it is white in color, most of our consumers also like it. So we also have CRI-Ewol. CRI-Ewol is also yellow in color, and it has more than 15 microgram of the provitamin A in it, and it's also high yielding. We also have CRI Harvest Plus. It also falls in the same category, high yielding, intermediate maturing, and also have appreciable level of provitamin A. All these varieties that we have developed are climate smart, and there is urgent need for all the varieties to get into the hands of farmers. With the iREACH pack, we have demonstrated all these hybrids for our stakeholders to come and appreciate. If they need be for them to license it, I believe if that is done, promotion will be wide and adoption also will be wide.
My name is Dr. Felix Frimpong of the CSIR-Crop Research Institute. I'm a research scientist and I welcome you to the iREACH Technology Park sponsored by CORAF and then the Food Resilience Program. Specifically, I welcome you to our upland demonstration field. And here we have upland rice. We've released 3 high-yielding, aromatic, long-grain upland rice. We all know that these days climate change is a huge problem for all of us, and farmers have issues with drought, they have issues with flood and all manner of things. Water is diminishing year in and year out. Specifically in Ghana, this year we've received in the major season less than 500 millimeters of rain. And so technologies such as upland rice can be grown or rolled out in marginal areas where you have low amounts of rainfall. And as you can see, despite the shortfall in rainfall that we've had this year, we've still been able to achieve this tremendous progress as is seen here. Now over here we have 4 varieties, 3 improved released ones. We have Nerica rice as our check, and then we have CRI Kafasi upland rice, CRI Cho upland rice, and then CRI Ofosu upland. So all these 3 varieties are upland materials. And by growing upland or promoting upland, we are helping farmers to adapt to climate change. Because even with reduced amount of precipitation in the form of rainfall, you can still have something, or you can grow your upland rice just at your backyard and you are good to go. Now, these upland materials, as you can beautifully see here, yields as high as 6 tons per hectare. In fact, on researcher managed fields, we are able to even have 8 tons per hectare. But on the average on farmers' fields, you can get 6 tons per hectare. It is aromatic, it has a lot of fragrance. We can attest to it, and it is long grain, just like US number 5 rice. That is aromatic. Ladies and gentlemen, in this time and age, this is the way to go, to have technologies that are resilient to our climate. And it is important that we promote such technology. Thank you.
My name is Dr. Victor Echampong Amankwa. I am the head of section for the tissue culture of the biotechnology seed and post-harvest division. Normally we hear about tissue culture. So what at all is tissue culture? Plants grow in their natural environment. So why do we have to worry ourselves to bring plants from the field and establish them in the lab and send back to the field? I'm here to do exactly that. Tissue culture is growing plants in vitro or in glass on a defined nutrient medium under aseptic conditions. So we do that to mimic what happens in nature. But tissue culture helps us to produce certified clean planting materials in large quantities, which cannot happen in the field. Tissue culture involves a lot of processes. It starts from getting samples from the field. So when we take samples from the field, we put them in the screen house and do what we call preparation of mother plants. Tissue culture is very useful for producing clean planting materials for our root and tuber crops, such as plantains, banana, sweet potato, cassava, yams, and taro. Tissue culture involves a whole lot of processes, starting from preparation of mother plant in the screen house. So you come to initiation. So you bring your samples to the lab and do initiation. So the initiation involves using bleach to clean the plants from pathogens. So when you are doing initiation too, you also clean the materials using thermotherapy by treating the plant with heat. So when you are able to get your clean planting materials, the next step is to do multiplication. This is where we produce large quantity of the planting materials. So within a very short time. So when the large quantity of planting materials are produced, the next thing to do is to put them on rooting media to help you get more roots. So tissue culture has the temporary immersion bioreactor system. And what is showing in the video is the Rita temporary immersion bioreactor system, where plants are able to grow within a very short time, more than the conventional type. And it's able to get more plants than the conventional type. Yeah, so the system is semi-automated, whereby a pump is connected. The pump pumps the media to the plants, and it does that 2 minutes in every 2 hours. This helps the plant to get enough media, depending on the protocol that has been set. By so doing, the plants are able to grow within a very short time, that is within 3 to 4 weeks. The growth room has bulbs which provides sunlight, and the lights are on for 16 hours and they are off for about 8 hours. It also has air conditions. The air conditions provide the plant with a very serene atmosphere for growth, and it's at 24 degrees Celsius plus or minus 1. So when you're able to get more roots, then you send them to the screen house where we do acclimatization. So the acclimatization helps us to gradually introduce the plants produced to natural environment. So when we are able to do that, then we send the planting materials to the field where they are able to survive and grow alongside conventional planting materials. This whole process, in the lab, between subcultures, takes 4 to 6 weeks. Acclimatization can take about 3 months. Then you have your whole plant ready for use.
My name is Samuel Azuk Ndebila. I am the Partnership and Business Development Consultant for the CSIR-Crop Research Institute Technology Park program. What we basically seek to do at the park, as Prof and other team members have already discussed, is to invite all stakeholders in the agric sector. If you are an investor, you are a farmer, you are a community development organization, we want to work together to see how we can scale the technologies that have been developed over the years. That has been a challenge, but we know that crops varieties have seen significant adoption, but what is left is to see how we can make impact at scale. And that is the reason we are showcasing all these technologies at this technology park. We have set aside special days that we use to showcase our technologies. These include field days, open days, and our doors are always open. Come and observe the technologies that we have. But you can also contact us as and when you hear of these dates that are being announced, so you can take the opportunity to see where we practically demonstrate our innovative technologies that will help drive the agricultural growth, and then make discussions or informed choices that can come out with better policies to shape the scaling of these agricultural technologies. We are inviting every stakeholder. If you are an investor, you are a financial service institution that want to support and fund agricultural activities, you are also a farmer, both like small and medium enterprises in the agri sector across the value chains, you can come on board. If you are also a technology developer who has developed a certain kind of technology to support the agri sector, you can come and exhibit these technologies at the park. If you are also a processor, an exporter, you can come, take up these technologies and see how you can support the scaling of its adoption, not only in Ghana, but within the sub-region. We also invite media partners and anybody who has a stake in this agri enterprise to come on board. Though we have the open days, which I've already explained, we also open our doors every day in the working week to potential investors and any stakeholder who wants to know more about the things that we do at the Crop Research Institute, based in Fumusua. You can contact us using our address as is displayed on the screen, and also use our various social media platforms to contact us for further discussions about our technologies. Welcome to CSIR-Crop Research Institute once again. Welcome to the CRI-iREACH Technology Park. Welcome to Fumusua, where we try to showcase technologies that can move agriculture sector forward. My name is Samuel Azuk Ndebila, Partnership and Business Development Consultant for the CRI-iREACH Technology Park. Thank you for listening and welcome.